covering the entire surface. A human-only mission is destined to fail. So the notion here isn't just to reduce risk to those humans. It's to reduce the risk of failure on the mission. Well, these are all male robots because they're tethered and they have no onboard intelligence. Okay. And conversely, I think that unmanned missions aren't adaptive, and there are unanticipated things that go wrong. This particular system has a microphone, 2 speakers. Without robots, we can't do it. Without people, we can't do it. It's the combination that will enable the entire mission to succeed. We're going to be very challenged.
It looks like this one. Is this the one with the variable focus? It looks like
yes, it is. Yeah. There are a wide variety of tasks that humans simply can't do. When we're in those spacesuits, we're not going to be able to just lay on our back and look up underneath. Inspecting this habitat, for example, there's a lot of confined spaces here, and we do not want to get into the situation where we have to disassemble half of the habitat just to replace one little wire.
Okay, so these are actually the wooden structures we'd actually take a look at. Yeah.
It's one thing to use robots for inspection and maintenance, but can they help astronauts explore where it's too dangerous for people?
Okay, so here's a plan.
The mission today is to go to the rim of a steep canyon and to attempt to explore it from the canyon rim using telerobots.
We're going to lower this platform down a steep slope that was probably too steep for a human EVA team.
It's a long drive out to the canyon, and on Mars, trips like this might be better accomplished in pressurized rovers that are like sport utility vehicles. On the other hand, it's very convenient to be able to hop on and off ATVs. In the years to come, researchers here on Devon Island hope to compare the two kinds of vehicles.
Capcom to EVA crew, I copy you, and I'm 23 minutes into your EVA, over.
After an hour of difficult driving, the EVA crew hits the treacherous rocky terrain leading up to the even more treacherous canyon.
This looks great.
On Mars, one misstep at a place like this could be deadly.
That is the most interesting thing to employ the robot on.
This is my first time, folks. You probably got a better perspective of that than I. Over. Yeah, now tell me that you would go over this in a spacesuit.
No, I can get over that in a spacesuit. Let's say we're on Mars and we came to the edge of a steep canyon like this, and Mars has plenty of steep canyons. We want to explore down there. Well, I don't want to climb down there in a spacesuit. Certainly don't want to have to try to climb back up. So we send down a telerobot.
Okay, here we go, Brent.
It is 4:25 p.m. and you are 2 hours and 10 minutes into your EVA, over.
Did you want to hit that for me? Take that apart.
We're preparing to deploy the robots to the bottom of the valley. It's very steep, and we would not want to go down in our spacesuits, so this is the spot for rovers. Over.
Okay, functions check. Camera going up. Okay, lights right.
Yes.
Okay, mobility forward.
We're sending it into the abyss. He's moving. Oh yeah, this is good.
This is very Martian-like in many aspects. If you look at the screed, the lack of erosion here really makes a lot of sharp, jagged rocks, which makes it very hazardous for us people. If you take one fall down here, you've got a lot of rips and scrapes all over the suit, and you've got some trouble. It's very slow, but it's a powerful system. The real tough part is handling the scree.
The rover has a panable camera on it, and it also has a variable focus lens. I'm gonna do a little focus here. That's pretty. So you can see all the way up to a rock that was right in front of the rover. to the area across the canyon.
What we demonstrated today was the ability of a human EVA team on Mars to take tools like this and bring them out to the field and deploy them in the field. These are tools. These are not substitute people. They are tools for people. What we showed here is that a human crew, with all the limitations of the EVA suit and everything that it implies, can use tools like these, which will greatly extend the reach of human explorers on Mars. All right.
Perhaps the most important mission for future Mars robots will be to help figure out where it's worth landing humans on the vast red planet. In the coming decade, more than a dozen reconnaissance robots are supposed to be sent out as scouts. One possible design for a Mars robot is being tested out on Devon Island by a group of graduate students from Carnegie Mellon University. It's a solar-powered autonomous rover that can explore extensive areas while planning and adapting its route such that the fixed solar panel constantly faces the sun and always stays out of shadows. Efficient, robust robots like this could explore non-stop in the polar regions of Mars, where during the summer, just like here on Earth, there's constant sunshine. This is another robot concept being tested out on the Mars-like Devon Island terrain.
Ready?
It's called Bob, short for Buoyant Observing Balloon. Martian landers could drop dozens of these cheap balloons on the red planet. Blown around at random by the Martian winds, they would float over vast stretches of the planet, snapping close-up photos of the ground and beaming them back to Earth, along with information about where each photo was taken. But perhaps the hottest concept for doing reconnaissance of Mars is to use small, almost toy-sized airplanes. To see what kind of imagery a Mars airplane would actually collect, NASA scientist Kelly Snook will fly over Devon Island in a helicopter at the precise cruising height of some of the proposed designs. Although Kelly isn't dressed in a spacesuit, her work is part of the most elaborate simulation being undertaken this summer on Devon Island. The idea is to see how much we can learn about a place from photographs and video before astronauts actually go there themselves. After a 40-minute flight, the images are beamed from Devon Island back to a team of scientists at the NASA Ames Research Center near San Francisco.
What do we think those are?
That other little pool.
We started from the large perspective.
The point that we thought looked interesting.
They're pretending to be the kind of science operations team that will someday support a real human mission to Mars.
Okay, so
using satellite photos, as well as Kelly's aerial images of Devon Island,
here's the topo.
They pick out areas that look especially interesting, ones that might have water, or might have fossils, or even present life. These will become targets for the next habitat crew to explore. What's unusual about this new crew is almost everyone works for NASA or has played a key role in past robotic missions to Mars.
The first cup of Mars coffee.
And then you...
Before they go out in spacesuits to explore the sites selected by the science support team, the crew will do some of its own reconnaissance with robots driven from the habitat. Unlike controlling Mars robots from Earth, where the distance between the two planets creates a huge time delay, robots can be driven in real time from a Mars hab.
Peter, you're first up driving, I guess?
Mm-hmm. Peter Smith was the designer of a camera that flew to Mars a few years ago on the NASA Pathfinder mission. Like all members of the crew, he needs a crash course in robot driver's ed.
Okay, I've got the up and down on camera tilt.
The location of the habitat is very appropriate to Mars.
This camera.
But it's also very challenging terrain with which to try to maneuver these things.
Stop me dead, you know, then I have to back up.
If you try to teleoperate or remote control your kid's car on the street, not very challenging. Uncluttered environment, no problem.
Whoa.
It's when you get this density of huge, very aggressive, ruptured terrain that's very cluttered and very complex.
It's kind of like surfing.
Yeah, really. That's when the human cognition really is challenged, maybe beyond the threshold of certain operators.
It's hard to tell how far we've gone, John.
Yeah, you're right.
I mean, we've covered a lot of distance according to the camera. But look at this view. I mean, you see every rock out there. Let me focus. And if you wanted to find fossils, this is the way to do it.
In principle, what you'd like to be able to do is send your robot out to do your sort of pre-EVA reconnaissance, so that when you go out on EVA, you've done that already.
Okay, that looks like the crater in front of me there.
One of the things we're trying to evaluate here is how useful is that experience. You know, if it's not useful, then maybe you dispense with that part, or if it's invaluable, then maybe you know that, hey, you got to have this kind of capability when you go to Mars. You just don't go without it.
Well, I think we're headed towards the crater.
Once everyone can drive the robot safely, it's time to go out and explore the #1 priority site selected by the science operations team.
Okay, so here's the latest uplink from the Science Operations Center at NASA Ames. Familiarize yourself with Site 6 using air photo. In fact, we did look at them.
The Ames science team has sent a marked-up photo of a place simply called Site 6, indicating their interest in a rock wall outcrop that borders a narrow valley. Within hours, the Habitat crew heads out to explore Site 6 using real-time remote-controlled robots. Had their low-budget radios reached all the way into this valley, they could have done the driving from inside the habitat. But now they just have to pretend they're in the hab, where of course they wouldn't have to wear spacesuits.
What we're trying to do here is prevent the operators that are going to be operating these robots from actually seeing the site, and so limit their perspective to what the robot sees.
Okay, drive straight forward.
At the controls is Carol Stoker, a NASA researcher and Mars Society member who has spent nearly 2 decades developing strategies for exploring other planets with robots.
We have gone to the coordinate they specified, and we have plopped down, and sure enough, the outcrop that they asked us to go look at and sample is sitting right next to where we plopped down, and I turn on the eyes of the robot, and boom, the outcrop is right there. No muss, no fuss, no searching required.
Carol moves the robot up to the rock outcrop to see if she can spot any layered materials that might contain signs of past or present life.
Focus.
The robot cameras don't spot any obvious signs of life. So now it's time to move on to the next objective, collecting a rock sample.
Look,
Looks
you
like
can see
there's
stuff in the water.
yeah, there's
there.
green
This is
stuff.
really interesting.
Go peek at that rock there.
You're up close to it, all right.
Here. There you go. Now close it.
Oh man, we've got it! Oh, that is awesome!
Play this.
Sample of a rock from Mars. We got to take this rock.
There you
I'm
go.
sorry, but
Is that it? Okay,
we
this
have
is the
got to
souvenir rock.
collect this rock. Ah!
Carol, he dropped it. Go get it.
All right. I'm going back after it. The advantage of these teleoperated robots is that even though they aren't anywhere near as efficient as a human would be, once they're in the field, you effectively have infinite time with them. These kind of tools you can sit and have and teleoperate them for 12, 16 hours. It wouldn't, really be any big deal at all. We're bringing the sample into the airlock now.
You can't do that. We'll die from the Andromeda strain. She was...
It's the last morning of the simulation, and the crew plans to finish their Site 6 experiment.
Juice for breakfast.
Well, it's my hot shower for the day.
Hazelnut cream-filled wafer cubes.
Well, the next step beyond sending the rovers out to these sites is to go on an EVA in spacesuits to explore it as astronaut geologists and see what we can determine with the constraints of suits being there only a limited time because the amount of air in our backpacks is limited, our mobility is limited, our vision is limited by the helmet and so forth.
You got air?
Got air.
And the question is, how much more can we learn as human astronaut geologists rather than robot astronaut geologists?
We're building on that reconnaissance made yesterday, and we're going to see what humans can see and how much more they can do.
Women and children first.
By the end of today, the story of Site 6 will be a condensed version of how scientists imagine exploring the real Mars. First, machines controlled from Earth got images of the site. Then real-time telerobots added to the knowledge of Site 6. And now the full power of the human senses will take in all there is to see and learn.
You can see the tracks of the robot. That's the last time we saw it.
Right, there's my track.
Almost instantly, Carol Stoker spots something very significant that she never saw with the robot's camera.
What I noticed quite quickly once we got back to the outcrop was that on one side of it, there was a lot of orange lichen. We didn't see that telerobotically at all.
One of the key systems on the human being is the ability to analyze what is being seen, to make sense of it, to put it together. You see something bright and orange on top of a rock, but hidden away. You can almost immediately tell whether it's life or mineral.
We saw this clear evidence of life that the robot missed just because we had this mobility.
Just a few hundred yards up the hill, the crew finds something else they hadn't seen with their telerobots: geometric polygon patterns in the Devon Island soil. The clearly defined lines are created by the repeated freezing and thawing of water. You can find them all over the polar regions of the Earth, and often if you dig down into the cracks, you can still find ice. There are similar patterns seen in satellite photos of Mars. The implication is there was melting and freezing of water there, too. And where there was water on Mars, there also could have been life. But to find and explore polygons on Mars, it might take the eyes and judgment of a human, just as it did to see what was really here at Devon Island's Site 6.
I think that robots are not sufficient for the exploration and understanding of Mars. And that's because we will not know what robots have missed. By sending humans, there's no guarantee that we will find everything. But the chances of humans missing something that the robots would find are small.
That's typical of glacial meltwater channels right here.
And that is because robots are programmed to find what they're programmed to find.
Let's go. It looks really obvious from here.
They're not very well suited to really improvise in the context of exploration. Robots don't explore themselves.
Peter, can we get a still photo of this? Because there's other examples here.
Okay, so I think we've used about 2/3 of our oxygen on this trip. Okay, so we'll head back. We'll take the flow road back and try to catch as much as we can on the way, okay? Roger that.
With the exploration of Site 6 completed, the entire summer field season is now winding down. It's clear all the participants survived the 6-week simulation, but would they have made it on a real 2.5-year mission to Mars? All hope that at least they learned some important lessons to help pave the way.
It's very clear to me that we are, as we're going through this whole exercise, learning specific lessons that just need to be confirmed by more experience.
You want to go out, you want to go EVA. It's tiring, but you want to do it again and again. You want to go to new places, you want to explore. But you're going to have to pace yourself. You're going to have to interweave EVA days with habitat days for the sake of doing the analysis of the samples and photographs and so forth that you bring in. This is filaments.
It's the bottom line is what are the rules and what are the parameters that we're going to need to go to a planet like Mars. You just can't pull them out of a hat. There's no book you can get from the library that tells you what to do.
Before we can just launch ourselves into a big program like this, we need to do some homework. This is what NASA's participation here is about. And until we have answers to specific questions like what kinds of tools we will need, what kinds of spacesuits will be needed, and what types of humans will be necessary for such a mission, and what kinds of robotic assistance will be needed.
Good boy!
We won't quite have the solution yet to our problem.
The plane's here. I gotta go.
6 weeks after arriving on Devon Island, the scientists, engineers, and Mars Society volunteers are heading back to the earthly comforts of home.
Got a big one coming through.
Soon, the cold and sunless Arctic winter will take over here.
As you know, the patch cannot be purchased. It is only awarded.
But next summer, these pioneers plan to be back, continuing to do what they can to make a human mission to Mars come true.
Let's go. You're a great guy.
See how it goes.
Thank you, Pascal. You're awesome, man. This is a fabulous project. Many times over.
It's very dangerous.
I know.
Okay, you ready to send?
Okay, you got the science instrument, hammer.
Okay.
So what are you seeing down there? What are you seeing?
I can't hear you.
Do you see any fossils?
Fossils, yeah. I think there's evidence of Homo erectus here.